this session we are going to derive expression for capacitance of a parallel cylindrical capacitor. We have two cylinders here. This one positively charged cylinder is kind of wire, cylindrical wire, and this is the negatively charged cylindrical wire. Here we have a charge density, linear charge density lambda. We have like three kind of charge density. One is a linear charge density, another is surface charge density, and the volume charge density. For this system, we are assuming here the charge is uniformly distributed over the infinitesimal length of this wire. This wire is the infinitesimal length, is a big wire, and these two big wire are parallel to each other. And here is the surface area is not that significant, means the charge is fully distributed along the length. That's why we are taking the lambda. Lambda is the charge per unit length. So here we have a lambda. This lambda is charge per unit length. Here there is a plus lambda and this one is minus lambda, charge per unit length for this negative cylinder. The cross-sectional area, here the radius of this cross-sectional area is A, and the distance between these two parallel wire is B, right? And now we need to find out the electric field at any point x, at any point P, x distance from the cylinder 1. This is the cylinder 1, this one is cylinder 1, and this one is cylinder 2. Okay, electric field between this, we can apply a Gaussian law over here, means electric field will be uniform here. So electric field over the area at this point will be equal to the total charge divided by epsilon naught. That is a Gaussian law. The electric field, total electric field over the surface area, this integration of electric field over the surface area will be equal to Q, total charge inside this area divided by epsilon naught. Now we'll see how much charge will be there over here. So let's take, for simplicity, take a length L. Right here we have a length L. Let me draw a diagram, separate diagram for this. So here this is my point, this is my point P, this point P at x distance from the surface. Here we'll take a length L, this length L, this point P, length L, and here we will draw a Gaussian surface over this. Here we have a cylindrical wire, this is a cylindrical wire. Let me choose another color here. This is cylindrical wire, this is cylindrical wire. Okay, here length L is the wire length L. Okay, charge per unit length, and this one is your surface. This is like Gaussian law, Gaussian surface. So here it will be like this kind of yes, this one. So if you rotate this line along this axis, this is the axis, this is the axis. If you rotate this line along this axis, you will form a cylinder, and this is the area, this is the surface area. So how much surface area you are going to get? Surface area. Okay, so this one means this total circumferences into length is the area. Circumferences is what? This is the x distance, then 2 pi x into L. 2 pi x into L is the total area. So total surface area will be equal to 2 pi x into L. Okay, 2 pi x into L. Okay, this is the total area. Now what's the total charge inside this surface? Total charge inside this surface, because total length is L and the charge per unit length is lambda, then total charge Q, this charge will be lambda into L. And what about this total integration of the surface? Means E will be uniform at each point. E will be uniform at each point, then E will be constant, and total area is 2 pi x into L. Then in this integration will be E1 due to surface 1, due to cylinder 1, into 2 total area 2 pi x dot L. That will be equal to total charge lambda L and epsilon naught. Then your E1 will be equal to lambda divided by 2 pi epsilon naught x, 2 pi epsilon naught x. Similarly E2, what would be the value of E2? Here E2 will be equal to minus lambda into L divided by 2 pi epsilon naught. What about this distance? This distance means the distance of P from the cylinder 2. The total distance is a B. So B minus A will be this distance. The B minus A. We need to calculate here this distance. This is B minus A. B minus X, not A, B minus X. You put it here, B minus X. Then total electric field will be E1 plus E2. E1 plus E2, total electric field. Okay. Yes. If we put the direction, in the sense of direction, the electric field direction of E1 and E2 will be same and will be toward minus charge. Means E1 also from plus to minus and E2 also from plus to minus. Then this one will be plus. This one will be plus. Okay. Then total electric field E will be equal to E1 plus E2. Okay. Now E1 plus E2 means this one we have a constant lambda 2 pi epsilon naughts and L are constant. Then take this constant out, lambda L 2 pi epsilon naught 1 by x plus 1 by B minus x. This is total electric field. Now our usual formula to find out the volt, to find out the potential difference between the two surfaces. The V will be equal to V plus V minus minus V plus, right? And that will be equal to, this is our minus V, and according to the formula this will be equal to plus A to B minus A, plus A to B minus A, E into dr, E into dr or dx here. Okay, then minus V will be equal to minus A by B minus A integration of lambda L divided by 2 pi epsilon naught 1 by x plus 1 by b minus x dx. This minus and this minus will get cancelled. Okay. Then total V will be equal to lambda L divided by 2 pi epsilon naught integration of 1 by x plus 1 by b minus x into dx right. Now integration from a to b minus a. You do this integration, you will get this value v will be equal to lambda by pi epsilon naught log b minus a divided by a. Okay. Now what is C? Here C will be infinite. There is no concept of total C here because we are assuming here this cylinder is infinitely long. Then here we will have a concept like capacitors per unit length. So capacitors per unit length will be like charge per unit length divided by V, means C, this capacitor per unit length. Here when we write C, it means the capacitance per unit length. This C is capacitance per unit length. This will be lambda by V. Then from here we can find out the relation between lambda and V, and then we will get this is lambda and V, then we'll get the C. So in this case we will get the C per unit length will be pi epsilon naught divided by log b minus a by a. This is the formula.